Hi, I'm Lars. Welcome back to the C# workshop. There's very little left in classes and objects. There's actually a ton left, but for this video series, this will get you through and get you up and running. This video is going to cover delegates and events. Now, these are kind of cool. I don't know why a lot of people don't use these as much as I do, but they're really cool. It's part of the observer method, and I'll talk about that a little bit in the video. So if you're ready to get into this, let's get to it. Just like the last video, this video will get you the information that is needed to learn C#. In order to get the most out of these videos, I recommend watching them in their intended order. There will be deep dive videos after the course. So this will be a simple example of how a delegate works. I'm not going to get into all of the details of what the program is doing, because that we could do in a later deep dive. But if I get into that, that's going to confuse everybody about exactly what these things actually do. In this example, in the program class, I will make a call to a worker execute method. We'll send in hours, and we'll sending two delegates, one for progress and one for complete. The way that these things look, we're going to concentrate mostly on the worker class, is we need a delegate defined. So these are called delegate prototypes, delegate declarations, definitions, whatever you want to call them. Originally they were called prototypes. So they always end up with the word handler at the end. I don't know why, it's just something that happened. Maybe it was to keep these from getting confused. So that, or if you're going to use them within the same class, that would make sense, because you might have a method in here called progress. So in execute, you have the int hours, progress handler, progress, complete handler, and complete. The way these are defined out is you have your public, your delegate, whatever the return data type is, and the name of the handler. Typically, it's whatever you're calling this progress. This would be progress handler, like complete handler. And then whatever you're going to send back to that method. So remember, this is a pointer to the method. So these are defined within the worker class because this is what the method has got to be set up as. Inside of execute, I'm just going to explain what this is doing really quick, and then we're not going to talk about it again. We're going to take in an amount of hours. It could be 40, 50, 100, whatever. We're going to do a random number. Okay, this is a generator. It's going to seed at 1. I is a double. We're going to walk down this code here while I is less than the amount of hours. All we're going to do is sleep for half a second. The sleep takes in milliseconds. So if this here would be 1 second, so 500 would be a half a second. It makes the math really easy. We're going to grab the next random number, and then we're going to add it to whatever I is. That's it. So these are just going to increment until they get past hours. The result coming back is going to be a percentage, and I wanted that as a whole number, not 25.3, whatever. It's just going to be 25, 29, 30, just a whole number. But in order to do the math here, you need to take I needs to be a double. Now that's either going to be, so you would either have needed to cast this as a double here, or just make it a double at the top. The reason is, if you take 1 divided by 100, you're going to get 0.01. If this was not a double, you would end up with 0 back. And this would stay 0 the entire time until you hit 100, which it would never hit. Well, I would hit 100, and then eventually we go 0, 100. So if you need to know more information about that, drop a note in the comment. Regardless, after all these calculations are done, or as they're being completed, each one, every time we go through the loop, we're going to call progress, and we're going to send this result in. This and this are linked together, progress and progress, and they're also linked together through this delegate defined here, the progress handler. And then complete is here and complete is here. So let's make this very clear. A delegate is nothing more than creating a data type, which is right here, program handler or complete handler. These data types define the prototype that you can use for the method. Not what's in it, just a prototype. Once those are agreed upon, and you have this progress sitting here, These two are a pointer. This is a method pointer back to here. All right, back to here, which is pointing back to here. Pretty simple concept. And once you play with these for a little bit, you'll get the understanding of them. Hey, if you think there's too much information to remember, then like and subscribe to the channel. Then you'll have a URL that you can go back and look at anytime. Over here in progress, this is just a bunch of formatting so that I can put right result out properly for everyone to see. When complete gets hit and called, we're going to put down here right line. Actually, we're going to put right line like that and put complete. Ding. Everybody's happy. So let me run this through one time so you can see how it runs. Complete. So as you can see, there's 100%, and when complete, it's called complete. Now this is good for very specific cases where you need to call into something like copying a file, and you want to display the progress and the completion in your own way. Okay, so we could change this any way we want. We would never have to go back and change the worker. That could actually be sealed. It could be hidden away from everybody. That code may never be touched ever again. For a bit of a change, we're going to convert these over to what's called an action. And actions are the more modern way to do this. So an action looks like this. Now you don't need to create these. These are already been created, and we're just going to stay away from these for, we're only going to step into these for like a second. Actions are defined. They're generic methods where you can push any data type in you want. And there's actually, these are overloaded all the way up to 16 different types. Okay, so there's one method out there that has T1 in it, one that has T1, T2, one that has T2, T3, but you don't need to write any of these. These are all part of the system class library. So just a real quick lesson, think of a generic method as a method that can change its parameter types at runtime. That's it. Okay, I'll have a deep dive after this series, really quick after this series, because these are pretty important, but we need to get back to working on actions. So you don't need to set this in here, you just need to know that this is available. Now, if we get rid of this and this, we have issues, okay, because you just got rid of these data types. But you can use the action to put in here double, and you can use this and just put action. Everything will work the same. Everything is mapped up the same. Everything will work the same. And I'm going to show you this by running this. But first I'm going to set this down to 250 milliseconds. So as you can see, everything worked the same. Same methods got called and whatnot. Now, let's just step into this one quick time, because what I want to do is get you to the next part. We go into execute, we step in, and we come down. This guy just keeps on calling. So this progress is pointing to void progress double, and the target is null. So that means that it's back here in a static. It's not actually to an instantiated type. But it will step in here, and then we'll figure out that, you know, how many, the value is equal to 1, the string length 1, so we're going to pad a 0 on the front of it, and then we're going to come down and write it. So then you're going to have 01%. And that's what you're seeing right here, 01%. And it's just going to keep on doing this the entire time through the while loop. And you're going to keep on seeing this thing get incremented, random numbers, whatever, you know, the end comes in. Like this is a 3, so now this is a 6, and now you got 6. So you jump from 3 to 6. So that will do that the entire time through the while loop. And once the while loop's done, you hit complete, and you go down to the complete. So if you've coded before, this seems pretty cool, like right off the bat. Maybe if you've never coded before, this seems pretty cool. If you don't understand it, drop a note down in the comment, and I will try to get you on the right track of how to figure this out a little better on your own. So something else that can be done with the delegate, although it's not used that often, but it's worth talking about, is just making a pointer to a method. This is something that may be done for a number of different reasons, but let's look as if we had a few employee objects in memory and we needed to access a method for their position in the company. This is a way it could be done. Again, this is just to show how a pointer method works, but it could be used like this in the real world too. This also removes the issue with if a bunch of conditionals going on, okay? And you'll understand more of that once I get this set up. So the first thing that we really need, and I've got all this stuff written up here on the side, you need a report class. Very simple. Like I said, this is not going to have a lot of guts to it. It's going to show you how the methods are moving through parameters. So this is just a report class which has one method in it called display, and whatever method is sent in, we're just going to call it. That's it. Nothing else. We're just going to call it. Now, in order to do that, we need to create a base employee. We're going to have 3 different types of employees, and they're going to be employee, a manager, and a director. But they're all essentially a base employee. They're going to have an ID, they're going to have a name, and just in the base object, I'm going to put show reports just to put the ID and the name in. Either someone forgets it in the employee, manager, or director. We're also going to inherit this from iEmployee because we need to call report. And we need to make sure that when we call report, we have a show reports method in the employee. So let me kind of show you how this works. The base employee inherits from iEmployee, therefore we have a show reports here. If I delete this, iEmployee is going to be upset. So we put it back in. We don't want it to be upset. All of the other employees, employee, manager, and director, employee inherits from base employee, manager inherits from base employee, and director inherits from base employee. So let me put these in their own vertical document over here. Inside of main, we need to have some sort of array. So there's a base employee, it's named employees, and we're going to use an object initializer to just add these employees in. Now, if you're following along and you're trying to type this in, as you start coming down, this is all going to get all red because there's a 3 here, and you don't have 3 of them in yet. If you just keep on typing or add the 3 of them in real quick and then put all the rest of the information in, then you'll end up with everything looking nice and pretty. So I'm going to put a breakpoint right here, and we're going to execute this part down to here, so then you can see the employees. They're all here. Here's employee 1, Lars, manager is David, and director is Nicholas. We're going to call into this report. And this report doesn't do anything but run the report that is called show reports, which is part of base employee. It's overridden in manager, and it's overridden in director. Employee doesn't have anybody reporting to them, so we don't need one there. We'll just use the basic. In fact, if we want, I could always put something in there like this. So we could put this in here, straighten that out, and instead of saying employees that report to this manager, we could say nobody reports to this employee, reports to this employee. And that would be fine. So they all look the same. They all call base reports, which is going to call up into here, and then we'll be moving on. So the next thing we need to do is over here in program is we need to call that report. So the way that we do this is we got to instantiate the report equal to new. And we need to put a for loop in here for employee's length. And then we need to call report.display. And we need to send in a report. So we need to call each of the employees. So let's go to employee. Doesn't matter who it is because it's in the base employee at position I. And we're going to call employees. We're going to send. We're not going to call. We're going to send show reports into display. So let me put a breakpoint there now. Need to put a breakpoint here at display. We go to report, we initialize, we check the conditional, go to display, which is here. We end up calling a report, which the target is application employee, and you could go into method now because it is an instantiation. You can check out the declaring type. You can look at all kinds of information. You step into it, you go into the base show report, into show reports of employee. That will call base show reports, which is here. It's the base employee. And you're going to write out the ID and name. You're going to come back and you're going to say nobody reports this employee, and you're going to come back here. Likewise, you're going to go to the next one. You're going to go to show reports. This one's for the manager, and likewise the same thing is going to happen, except for you're going to be on manager. Going to go to show reports, show the ID and the name, which is ID2 and David, and then employees report to this manager. If we had them, we would list them out, and then you're going to end up coming back to here, and this is going to happen for every single employee that we have. This one here is going to be Nicholas. He's going to get employees that report to this director, and then you're going to finish out, and you're going to get this on the screen. ID1, name Lars, every reports this employee, da 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 da. Okay. Now, why is this one beneficial? More beneficial, or is it more beneficial than the last one? It's not. Okay, so I'm going to swing back to the worker class now. This is a tool or functionality that is well known from front ends, at least desktop front ends, and is extremely powerful, but it's rarely used anywhere else, and it's called an event. Now, a lot of people think, oh yeah, I know what an event is. When I click on a button and I trigger on click, and you just add to the on click and you move on, stuff like that. That's an event. Well, events are also a little bit more than that. Events are very much in my bailiwick. I use them quite a bit. I use them with web notifications and a variety of other things on the back end. And when I usually tell that to someone that's a back end developer, they kind of look at me and go, okay, I'll bite. How? So what is an event? We deal with them every day in the real world. If you're driving down the road and a traffic light turns from green to red, you stop. When it turns from red to green, you go. If you're driving on the highway and you see somebody's turn signal kick on, you know that they're wanting to move over to either the lane away from you or into your lane or whatever. Those are called events. By definition, an event is an observable occurrence of pretty much anything that goes on in your life. If you've seen it, you observed it, you saw an event. There's a book called Design Patterns that was put out in the 90s. And if you want to know more about observable patterns, that's a really good book to get. I have no links to the book. Anybody, I'll put a link down in the description, but it's not mine. I don't know I don't know Eric Gamma. I don't know the Gang of Four. I'm just saying it's a really good book for you to read to learn more about all of these patterns that have been used over the years. An event works a little different than a delegate, but it's on the same premises. Okay, so a delegate is a pointer to a method. All right, one method. You can think as an event as a list of pointers to a plethora of methods. Now, there's this, with power comes responsibility. So if you add a method to this list, you need to understand, you need to take this method off of this list because you are using memory. And I usually recommend getting them off the list as soon as you can. In order to use an event, you need to have a delegate. Now, I'm going to throw this in the old school way real quick. I really feel like everybody should understand how this actually is working. So you have a public delegate, and remember we had the progress handler, and this was double value. I could learn how to type, great. And then this one here was nothing in here and was complete. Okay. So when you make an event, you would say public event, and then you'd put in here progress handler, and you would say it's an event. So like on click, you would say on progress. and that would be it. And there's the on complete. You wouldn't have this here, sorry. And there's the on complete. This would be nothing that you'd be doing over here. These here would disappear, right? So they'd go bye-bye because you wouldn't need them anymore. And down here, you would say on progress, result, and on complete. And everybody's happy. So you've mapped these back to progress handler like that. If we go over to program, the execute, this would no longer be here. And in order to call these, you would want to say worker dot on progress is plus equals. Now we're adding these to the on progress. So I'm going to put in here on complete. So that's something you got to keep in mind. And I'm going to run this real quick so you're going to see nothing's changed. And then we're going to take these out and I'm going to show you what happens. Okay, so you can see it ran right up to 100. Everybody's happy. It works the same. Now, if we didn't have these in here, which is a possibility, there is that possibility. So you as the person who's writing the worker side over here needs to keep that in mind. Well, we got a null reference exception because on progress is set to null. So something you need to do here is you need to put, you can either do one or two things. You can say if, so what you can do, there's one or two things you can do. You can put an if on progress is not equal to null and make the call. And you could do the same thing here for complete, but I'm going to leave that go. So if you were to pull this up here, it's going to say that's null. I'm going to put a breakpoint down here. If you step over this, see, it'll just step right over it. Or you can use what's called a null conditional, and that's one of these guys. If you do that, you're going to have to use invoke, and that's no big deal. So this has become more of a standard here, is just using the invoke. And honestly, if you call on progress straight through, it's going to call invoke anyway. The null conditional will go in and look to see if on progress is not null or if on complete is not null, then call their invokes respectively. Okay? So that's one thing that you need to keep in mind. Now, the reason I say that is because of this. Now, the wonderful thing about this, setting up with an event, the best thing about events is the publisher, which is the worker here, and you are technically publishing this someplace, right? It's not going to a centralized location, but these are, you have to remember, these guys are a list of delegates. So now that we have this down, we're going to go back over here to worker, and I'm going to remove these guys like that. And then we're going to add in here action double like that. And we're going to put action here. And that'll take care of the rest of it. You don't need these anymore. Now you could use them. There's not a problem with it. That makes you more comfortable. But this is usually what you'll see. Actually, the one with the handler is what you normally see, but this is the future of .NET Core. The beautiful thing about this is if you're the one writing the worker, you're done. You're pushing stuff to this on progress and pushing this stuff to complete. You don't have to worry about anything else. For everybody else out there, if somebody's like, okay, well, I want to go in and I'm going to have a subscriber. And this could happen, all right? Now, this is sort of dependency injection here, okay? Because I am pushing in the worker to do something. I'm not doing anything else. That's it. Subscriber worker. Now, the only thing that's happening with subscriber is we're taking input from the worker. So I'm going to go in here and I'm going to just take progress. In subscriber, we could have a private flag set 25. We could have a worker that is local. So when that worker over here comes in, remember this is a This is a worker coming in, and now we're making a pointer to that worker because it's a reference type. So this is making a pointer to that worker. And so our pointer to that worker sees on progress, and we're going to add show flag 25. So if we hit 25, at least 25%, right, 25 on the value, we want to say flag over 25. And we want to be good about it. We want to be happy about it. And then we're going to set flag set equal to true because we're not going to call that in. We don't want that just to keep on appearing and appearing and appearing. So we're going to put a breakpoint here. We're going to put a breakpoint on progress. And we're going to start this. Now, progress got hit first. Okay, we did. We're in here. You can see this is grayed out in execute. So we came down to execute. We hit progress, just like we did before. Now we're going to go down and go through progress. And we're going to display it. When we're done, it's going to jump right to show flag 25 because it's been added to this list also. And it's going to keep on doing this over and over and over again. So I'm going to put this in here like this. And once we get to 25, hey, we're in. We're going to say flag over 25. Then we're going to say flag set 25 is equal to true. So while this is false, we're going to run this. So we're not going to come back in here. And as you can see, we keep calling it, but we're never going back in. And that's a good thing. So that says flag over 25%. Wonderful. So now let's make a little change here. Say we wanted to do this like over 50%. Right? We're going to put a couple flags up here. Just make this one here 50%. Everything's pretty much the same. It's just going to be, one's going to be 50%, one's going to be 25%. There. Now we're just going to run this. I'm not going to do anything. I'm hoping you're getting the understanding of how these are working. So this is going to run up to 25, flag over 25, and it's going to keep on going. Flag over 50. Now, I want to show you something. We're going to put a breakpoint here and here. And these guys, I'm just hitting F5. These guys are always being hit. And that makes sense until that flag is set to true. Okay? So once that flag is set, so I was just talking about, you need to remove this from here. If there's no reason to make this call, don't make it. Same thing here. Stop making that call. All right. So I'm going to put a breakpoint here and a breakpoint here. And we'll get to this breakpoint in a minute. But you'll see this spin up to 25. We hit, and now we remove that. So we took that off of here. Now I'm going to put a breakpoint on the if, and you notice it's not being hit because we've removed it. And then we'll take the breakpoint over here and put it on the if. All right, like that. And if we go back down to progress, progress is still going to get hit, but the other ones will not anymore. And then you can just let this go. And that's how you keep your program. As your milestones are being hit, you can hit them. You can remove them from the progress. Now that you've removed this from the on progress, you don't need this anymore. You don't need this flags to be set because you're not going to call it anymore, right? So that also removes a lot more stuff from memory. Just thought you'd like to know. So what does this show? This shows that you can add functionality to a process this is just a copy process. Just say we're just copying a file. That's all we're doing. And we're just throwing that information up. And maybe you wanted some milestones. So you put some milestones in to say 50%, 25%, 50%. You could have done this anywhere along the way. But it's made this very extensible. Now, this is the precursor to extensibility, but real extensibility happens after you learn about generics. Thanks for watching the video, and please like and subscribe to the channel. I really hope you enjoyed this video, and I hope you now understand how delegates and events work. This is the book I've been talking about. It's called Design Patterns. I don't think it's in print anymore, but I think it went to like 22 different versions of being printed. I've had mine for a long time, but I take really good care of my books. There are 23 different patterns in here. The one that we just covered was over delegates and events. It's called the observer pattern. A couple videos back, I covered the template pattern. And when I get into more of stuff with abstraction and stuff like that, I'll really get into the template pattern and how powerful it is. And we'll start looking at some other patterns in there that you can use with the abstraction class. You're always welcome back here at the C# Workshop, and have a nice day.